Hello, everyone. I trust you are all as well as can be. Welcome to Frontline Systems webinar on Monte Carlo simulation and risk analysis using the power of Analytic Solver plus RASON. Thank you for joining us in this virtual gathering to briefly talk about and share some of the possibilities that Frontline System software offers to build and test your simulation models and then deploy and manage those models as cloud services. My name is Dr. Sima Maliki. I am happy to present this webinar. So during the presentation, which usually takes about 45 to 60 minutes, you're welcome to type your questions in the chat box. There's a chat box in the GoToWebinar panel on the right side. You are also welcome to download the handout that was also emailed to you if you didn't open it. It's a wonderful handout with a summary of what is offered in Analytic Solver plus RASON products. Okay, so this is our plan for today's webinar. We are going to start with a brief overview of Analytic Solver desktop and cloud. Then we switch to Analytic Solver to build a simulation model for a software development problem in a startup company. After that, I show you how with only a few clicks, you can deploy your simulation model to the Azure cloud to run it as a cloud service using Analytic Solver plus RASON. Next, we move beyond analytic models in Excel or RASON and show you how to work with Microsoft Power BI and use your models on the cloud, basically those cloud services you created. And then I'll show you also during this webinar how easy it is to run your Palisade at-risk models with Analytic Solver so that you can run them on the cloud or as cloud services and further use Office add-in and Excel for the web or Excel for Mac and enjoy the full power of Analytic Solver plus RASON for deployment of your models. If time allows, I'm planning to show you how you can actually create and run a decision flow using the model that we have created and posted to our as a cloud service. So you want to have a multi-stage decision flow starting with the simulation model and then using the simulation model in creating a decision table with business rules. And then I'm going to show you how you can do that. So hang in there. It's going to be like about 1 hour. Thank you. So we are going to use two tools today. One of them is Analytic Solver and the other one is RASON. Both of them are developed by Frontline Systems. Analytic Solver may be familiar to you, but RASON may not be. In a nutshell, RASON Decision Services is Frontline's Azure-hosted decision management suite, is the tool you can use to deploy your models. So our goal for you today is to start with building your first simulation model in Excel using Analytic Solver, and then I show you step by step how you can deploy your models for use across your organization. RASON here is your deployment platform, and actually it is the easiest way to deploy your models as cloud services, so other people can use your models and run them over and over again. I'm going to discuss a lot more details on deployment and RASON as we go along. Another good news is that with Frontline System Create App feature in Analytic Solver, you have a window into RASON so that it has created Analytic Solver creates a window into RASON for you so you can build, test, and deploy all within Excel. So let's start. Let's see. Okay. So if you install Analytic Solver, here's a ribbon that you should be seeing in Excel. I'm going to start with Analytic Solver desktop version. And then you can also see there's a data mining option. Today our focus is on risk analysis, Monte Carlo simulation. So let's start from the ribbon. Clicking on the model tab, you can see that it displays or hides the task pane. This section on the right is called test pane, and we go over it. On the model drop-down, you have additional options for multidimensional simulation optimization models. This is very helpful if you have large models and they change frequently. It's beyond the scope today, so I'm going to skip it. But if you're interested, there is a very good nice chapter and user guide, and we also have demo videos and much more. Simulation model group is next. Okay, so you can see that we have distributions, correlations, and results. This is the three components we will be using. These the three sections of Ribbon to create Monte Carlo simulation models. Click on distributions and you can access a range of predefined probability distributions. You can see we have common distribution, normal, triangular, uniform, then advanced ones, exotic, discrete distributions, and your custom distributions. You also have distribution wizard, and I will try to discuss it in more details. So distribution wizard is actually a step-by-step process. Let me just show you now. It's a step-by-step process that helps you narrow down all the choices and may help you make a decision to what distribution to use to represent or to model your uncertain variables. So it asks you a series of questions. For example, first it asks you, do you have historical data for your uncertain variable? And if you have yes, it helps you to fit, choose an option to fit a distribution to historical data. But if you say no, it actually gives you some ideas what to do and then asks you whether your underlying physical process involves discrete countable units. So it helps you decide and then narrows down choices about the different bounds and brings you down to just a handful of distributions. So this is a great tool if you're not sure what distribution to use. Then you can induce correlations and results button to compute the statistics, range measures, different values, maximum percentile, Six Sigma, and other results. Next is optimization model group. So you have decisions, constraints, and objective, the three components that you need to define an optimization model. Parameters tab allows you to define multiple parametric simulations and optimization models. So instead of sitting there and manually changing your input parameters and rerunning the simulation, you can actually define multiple parameter simulations. So run like 50 simulation, and each one can be any desired trials that you want. The default value is 1000. So this is how you run your simulation. Click on this drop down, run once. Then click on optimize for solving the optimization problem. Next is create app. This is the focus of webinar for deployment of our models. This is what I told you that gives you the window to RASON. This is the breakthrough bridge between what you can do in Excel to model and solve your business problems and what is now made available to you to create a version of your Excel analytic model that will run outside Excel. So with this create app, you're only a few clicks away from deploying our model to run it as a cloud service, which can be used by nearly any application. So we will come back here. You have different reports, charts, decision trees, fit distribution to your historical data, publish your models for use and distribution on the web. You can see there is an option to change the number of trials here. There are options here for cycling through individual Monte Carlo trials, simulation number. This is where you change the trials. Then you have get data. Get data allows you to bring data into Excel from different sources. This can be other databases. You can bring big data using our Apache Spark Big Data clusters. And you can bring data files, text files for data mining purposes, text mining. And it brings a statistical representative sample of your data. So that's the difference between the data tab on Excel ribbon and the get data into Analytic Solver. You have different options. This is where you can change some of the simulation options. For example, if you're interested to change random number generation methods. I can increase the size. Not really. Random number generation, sampling methods. So you have 3 different sampling methods available. Another option to another way to change the number of trials per simulation, and much more. So if you want to change this simulation engine options, this is where you can come easily on the ribbon, click on options. Now let's click on help. So I'm going to click on help to show you that through this button, you can access all the user guides, example models that we will be using today, and there's much more examples. So you can see they're all categorized based on the application area. You can see we have Monte Carlo simulation examples, optimization examples in different industries. So let's click on Monte Carlo simulations, and you can see we have finance, functions, investing, production, and much more. So through help, you could also look at your support mode, operating mode, and connect with our live chat. Now, let's briefly walk through task pane. First is model tab. Here you can see the outline of your model. For simulation model, there are different components. You can see we have uncertain variables, uncertain functions, and statistic functions. If you define correlation between your uncertain variables, you will see them under correlation matrices, and parameters if you have a parameter. Next is platform tab. Again, another way to change options for simulation or optimization. Engine tab, this is mainly related to optimization and different engines that can solve optimization problems. If time allows, I can show you a simulation optimization application. With Analytic Solver, you can solve deterministic optimization problem, also stochastic optimization problem. You have access to robust optimization and stochastic programming methods, and also simulation optimization. And you can use these optimization engines that are available to you. Some of these are additional plugin engines, and some of them, the standard ones, are shipped when you purchase an Analytic Solver license or when you're using a trial version. And once you select an engine, you can change all its options down here. Output gives you a message of what you have accomplished. So when you run a model, you get a message. If it's red, means there's a problem. Usually green means there's no problem, and it gives you some information of what you have to do next. And workflow allows you to define multi-stage data mining projects. And this is the topic, one of the topics that would be discussed during our data mining webinar next week. So if you're interested to learn about the multi-stage data mining project and how to get data, transform it using different classification prediction method, and score new data, you're welcome to join us next week. So now, let's focus on our example. I will leave the cloud version when we want to talk about running the Palace 8 example. So let's just focus on desktop and work on our simulation model. So this is a startup company with a great idea for a revolutionary new computer game. They want to create a simulation model that helps them estimate both the time and cost associated with this new product. As you can see, the development stages, let me increase the size. The development stages is a development process actually is broken down into different stages. You have market analysis, design, implementation, and so on. Based on their research, they have estimated the number of weeks required to complete each stage using a most likely, best case, and worst case scenarios. And you can see all the values are here. Accomplishment of project can be delayed due to various events, such as employee turnover, bad design. You can see potential delay number of weeks and the numbers that they have predicted. Also, they have listed the probability of such event happening. So a bad design can happen 20% of time. Delay can be costly. So you can see there's a column with the cost per week for each of the development stages and for potential delays. So now we want to use Monte Carlo simulation to estimate the total cost and required time to create this new product. So let's go back to our slide. I want to show you the steps involved in building a simulation model. To apply the Monte Carlo method, you can construct a model that simulates a real situation. And this is just like starting from an ordinary what-if spreadsheet model. You have some inputs and some outputs that calculates somehow you calculate a measure for some given values of input, right? Now, because it's you are including uncertainty, you have to identify your uncertain inputs and specify probability distributions for them using Analytic Solver. Then you have to select your outputs to record over the simulation trials and execute simulation for a number of trials and analyze the outputs. So let's go back to our model. Okay, this one. So just imagine this was an ordinary what-if spreadsheet model, some inputs, I have some outputs. Now I have to identify my uncertain inputs and specify probability distributions for them using Analytic Solver. So as you may recall, let's look here. For development stage, first stage is market analysis. I have number of weeks estimated. I have most likely, best case, and worst case scenarios. So what is a good distribution to represent this uncertain variable? And this is, for this one, you can use triangular distribution to model the estimated completion time in weeks for each stage. And this is because I could have used the distribution wizard. I can say, hey, it's a discrete distribution. I have 3 values, but the triangle distribution is very famous when you have such a scenario. But if you're not sure, you can use distribution wizard, answer those questions, and helps you narrow down. You can look into literature. And also, if you have historical data, you can fit an analytical distribution to your historical data. So you have more, and you can use actually, if you have historical data, you can use those results in a sequential basis or in a random basis. So there are various options that you have. For this one, let's select an empty cell and see how we can insert the triangular distribution to estimate completion time for market analysis. Select an empty cell, go to distributions, common, triangular. This is called an uncertain variable dialog. You have the PDF tab, then there's a CDF and reverse CDF. On the right section, we have parameters. So there's this drop down here. First one is parameters of this uncertain variable. There's this side in the right that you can open or close the parameter section. So let me show you. I want to make sure you notice this. So there's this right side that opens or closes. There's this parameter drop down. So you have parameters, analytic moments, percentile, chart type, and so on. In the parameters section, we can define the parameters mean, likely, and max. So let's update the chart. I'll move it to this section. It erases all the drawings. Which there was a way to increase the size, but okay, so the first is min, likely, and max. These are in order. So if min is larger than max, the chart would give an error, but once we finish everything, it would give you the result. So minimum number would be the best case in our market analysis, so D15. Now let's try most likely, which is most likely case, presented in cell C15. And then the max value is worst case, E15. Now the chart gets updated. And we can also verify, these are the 3 values, min, most likely, and max. and the parameters are now updated. You can look at analytic moments, percentile, you can change chart type, access options, and much more. As I click save, you can see the cell gets updated. I have a triangular distribution in cell F15 with parameters D15, C15, and E15. I have repeated the same step for all other development stages to save time. I have, let me show you the formula. So I have triangular distribution. Then I have multiplied the estimated number of weeks by associated weekly cost and calculated the total cost for each stage and then added all of them together. Okay. Okay, let's practice this one more time for potential delays with bad design. So let's estimate number of weeks with using a triangular distribution. Select that empty cell. You could also type in, but let's use the ribbon distributions. Triangular is a common distribution. Now let's update the parameters. This time I'm going to start from max and go back to min so that the chart stays up. So max time is worst case. Most like this is min. Let's first do most likely is 8, and then min is best case. Click on save. Oh, just before that, let me show you. There are some control parameters in the parameters section. For example, if you want to have a lower cutoff or lower sensor instead of negative infinity and have a cutoff value, you can actually add them here. For example, let's say instead of negative infinity, I want everything to, I mean, it doesn't make sense here, but let's say you want everything to start from 6, and when I hit enter, you can see everything below 6 would be rescaled to lie within the desired range after 6. Or if you want to have a lower sensor, instead of negative infinity, you can have 6, but it's a little different because everything that's below 6 actually rescaled on 6, the value itself. Okay, so there's a difference between lower cutoff and lower sensor. So let's remove this. Okay, so I don't want to have any of those, and click on save. Now, let's have the event occurrence. So we're using a Bernoulli distribution here for probability of each event happening. So select an empty cell, go to distributions, and then under discrete distribution, let's use the Bernoulli distribution that takes a value 1 with success probability and value 0 with failure probability. So now it has only one parameter, which is the probability, and I want to make sure to point to that 20% chance of failure. Okay, so let's move chance of the 20% chance of this event happening, basically bad design. That was what I meant by failure, the bad design happening. So can verify that you have done everything correctly. There's a 20% chance of this event occurrence, and then 80% chance of not happening. Okay, so this is how you can define Bernoulli distribution to estimate the occurrence of bad design. Now I have multiplied all of these with the associated with weekly cost, and I have the total estimated cost for each of potential delays. And now these are my two final uncertain functions that I have. One of them is number of weeks to completion. So I'm adding total number of weeks, total number of estimated weeks, and I also have total estimated cost, adding both the development stages and potential delays. So I35 and K35 contain our uncertain functions, which model the projected total number of weeks to completion and estimated total cost. Now, if you recall, we need to select the outputs to record over the simulation trial. So this is not enough. We have to tell Analytic Solver these are our outputs. There are multiple ways to do this. One of the way is to mark the cell as the output. So you just directly say, hey, this function is my output function. For example, this cell K35. Let me show you what happens. Here I have the estimated cost calculated K35. Why is it this color? Let me quickly change the color to something lighter. Okay. So you can see I have H21 plus K33, and I want to mark this as an output function. So select this cell, go to Analytic Solver, Results, Output, Insert. This is your first option. So it designates the cell as an uncertain function. And what it does is that it adds this PSI output to this function and marks it as your uncertain function to calculate trials and all the statistics that we need. I've already done this for a number of weeks to completion. So this is one way of doing this. Another way is to use a summary statistic. So if you use, for example, if you calculate the average cost on the worksheet, it actually needs to record over all the trials to tell you the mean or the standard deviation or the percentage. So that is another way to mark a cell as your uncertain function. So you can calculate a statistic function for that function. So let me show you how I did all these functions. So basically, select an empty cell, go to results. For example, let's say you want to calculate the statistic variance. So it says, please select the output cell for which to compute a result. So this is my output cell. And then please select the cell where the statistics would be placed. And I put this PSI variance K35. Okay, so this is how you can insert mean, standard deviation. I also have PSI data showing you all the trial values. I actually don't, I can cut that and paste it here. Okay, and then we have the percentile and PSI data. Okay, so I have all these calculations for you. So let's go ahead now. We can run one simulation. Simulate, run once. Okay, so we just ran 1,000 Monte Carlo simulation trials. On each trial, we have a different randomly sampled value for delay for each stage and event. Then we calculate the total cost and total time. This frequency chart in, as you can see, it's I35. It shows the distribution of all possible outcomes for our total time. And you can see that if you read these values, statistics related to I35, the estimated number of weeks could be anywhere from 49 weeks to 102 weeks with an average of 72 weeks. Okay, and let's click on, oh, let me show you what else is available. You have the frequency chart, cumulative frequency, reverse, and you have the sensitivity tab showing you a tornado chart, shows you which input has the most influence and how the inputs are influencing your this frequency chart. Okay, and then you have the scatter plots. On the right there up, then you have statistics, percentiles, you can have Six Sigma, chart type, and so on. Any of the outputs that are demonstrated on the chart section, under statistics or under percentile or Six Sigma, you can have them on the worksheet. So as I showed you how to use the standard deviation, you can do the same thing for mean or have all the trial values, calculate the percentiles, and much more. Okay, now K35 shows the distributional possible outcome for our total cost to complete this project. And this show what happens for these specific assumptions. So if you change any of the inputs, you can rerun and get the results. Okay. So again, we have the sensitivity tab and the scatter plots and much more. And as we requested, we get the mean values, we get the standard deviation, and this was the PSI percentile. It was a 95 percentile for a number of weeks to completion. This was my variance for total cost. Okay, so this was the data that present all the trial values for that for all the trials for that function. So I have all the 1,000 trials actually presented here. So we reviewed how to model and solve a business problem in Excel using Analytic Solver. Now let's move along into deployment using Create App. If time allows, I make a note to myself to show you how to induce correlation. Okay? So please make sure to remind me if you're interested in the during question time that I can show you how to induce correlation between two variables. Okay, so let's click on Create App. I want to show you how to deploy this model. Here you have multiple options, allowing our simulation model to be deployed to the cloud, Power BI, Tableau, or your own application on the web. First, I will show you two approaches to deploy our simulation model. We export the Excel model as it is in Excel form. Then we do it again with translation of Excel formulas, all the data to equivalent expressions and data. Excuse me, I need some water. Excuse me for that. So first we export the Excel model as is. Second, we translate everything to JSON modeling language, which basically wrapping JSON in RASON modeling language. And I'll show you what happens without any need for programming. So everything is just a few clicks, okay? And I want to acknowledge that you're hearing some unfamiliar terms. No worries, help is on the way. We will go over this in just a few minutes. So let's just follow with me. We built this Excel model. Let's click on Excel model to post this Excel model to our RASON account, to RASON server, to use it as a cloud service. You click on that button. You can just select that name that's given. You can change it. You could have your model on OneDrive. So let's click on Save. I just want to give a 1 to it because I might have used this name before when I was just checking it. Click on Save. This action saved a copy of our workbook in my account on public RASON Cloud Service, and it posts our workbook to RASON server immediately. The RASON.com opens, and this is the model displayed without any translation to RASON language. So this was what happened. Our Excel model itself is posted to RASON server on Azure. This is where you can communicate with RASON to RASON.com. This is our RASON REST API. This is the model. So this is an unfamiliar page for a lot of you. This just looks like Excel. You can see that. This is RASON.com. Let's see if I can increase the size here. So this is RASON.com. It automatically opened for you. Once you have an account for having Analytic Solver, you can use the same username password to create a trial version for RASON.com. This is the editor page. This is where you have the model. On the left side, you can see all the models I have on RASON server. All my cloud services, I use Analytic Solver to post them. Some of them are Excel models, some of them are RASON models. Here you have some execution options. These are some endpoints to solve and get the results. We will go over that in more detail. Since the model is already posted to our server, we can just click on post simulate to get the result. Down here, let me drag this up. You get an update, what is happening. This is the model name on the left side. You can see the results are now available. This is the model, this is the version, this is the result is now available. I can click on results and it gives me the results. All the statistics that were requested in the model. Remember, I have the trial, so it's giving me all the trial values, mean, standard deviation, and much more. Okay. Let's go back to Excel. Erase the drawings. Let's do this one more time. We have developed our model in Analytic Solver desktop version. Now we click on Create App to convert our model. This time from all the Excel formulas, we want to have the RASON equivalent of the model. So everything would be translated for us. RASON modeling language. So let's click on RASON model. And I'm going to give it software product simulation. Let's call it RASON. And click on Save. So it automatically translates the model to all the equivalent expressions. Here is the model, software product simulation RASON. This is the translation model in RASON modeling language, which is actually JSON. These are all the triangular formulas, if you recall, that we have for uncertain variables. And then if I scroll down, you can see all the functions that we have and then the outputs. So you can see that the model is posted to the server already for us. We have a version created, but there are no results, right? So now I can come to model execution and actually solve it. Click on post, simulate. Check to the left. You can see the RASON model results are available. So you can click on results to get the outcome. You can see we get a status code, all the uncertain values, trial values as I requested, mean, percentile, and variance. Remember I had the variance, it is here. With doing this, we used our Excel model as a RESTful service. We deployed the model to RASON server. First time, we maintained it in Excel. Second time, we used RASON modeling language. And everything was done for us automatically. Now that you have seen this, it's a good time to review some information about what is a REST API, what are we doing here, okay? And then we come back and do some more. Let's see. Okay. With RASON server, all these engines, the same power that you have Analytic Solver, the same power is available to you on the cloud, okay? So all same engines, everything is available to you. So if you have, for example, if you purchase a license to Groby, you will have access to Groby. Okay, so let's go back to our slides, talk a little bit more. So I trust you have learned how to start building a simulation model and then take a few steps to deploy the model. But there's much more that I want to show you that what you can do. So if you want to build a web application and have something with its own user interface, you will have a model. And for example, you want to deploy it for a large number of people. You want to set it up that it can be rerun or rerun on demand. For example, you have this financial application, you have this web page, people put their, for example, budget, and then you would give them a portfolio. Okay. So most web applications follow this structure. Your application is the client or front end part. On the back end, it needs to talk with the server to post the model, to solve it, to get the results, or update the model. When you send a request to this server, You want the data returned in a structured format. And in summary, data can be returned in JSON format or OData format, both of them available with our RASON server. API stands for Application Programming Interface. It's the way to connect you and the server. REST API is an API that follows the rules of REST specification. This is how the communication is happening. If you follow REST rules, you are using RESTful services, and you can use HTTP verbs such as post, put, get, and delete operation. If you recall, when I was on RASON.com, I was saying, hey, let's post the model is posted. There's a put option up there. There's a get result option. So we are following the rules of REST. That's why we call it RASON REST API, okay? So when you type a URL into an address bar of a browser and press enter, you are actually performing an HTTPS GET operation. So it's not, we have been doing this like every day when you're like browsing or typing something and looking for some, Googling something. The web server accepts the GET request and produces a response, usually HTML plus some JavaScript or JSON, and then it can be pure JSON, PDF, or another content type. So RASON REST API operates exactly the same way. So you can actually type things in address bar, and I will show you one example of web application. So another example is when you fill out this form on our solver or another web page and click submit button. This is our registration for Analytic Solver creating a trial account. You are performing a post operation when you hit proceed. Basically, the web server accepts the post request, including the post body. And post body is the form content. But when you do a post from Analytic Solver RASON, that's actually the post body is your model. And then it uses the data in some manner on the server for you. Okay. I hope this helps to make things more clear for you. I actually have another slide. So I wanted to show you here that what we have done so far, we sit in Excel, we use Analytic Solver to create our models, and then we use Create App, Cloud Service, and then we use RASON button or Excel to post our models to the RASON server to use them as cloud services, right? So what we did was the model automatically opened in RASON at the same time they were posted to the server. So now, once you created your models in Excel, then you can have the Excel version or the RASON version onto RASON server as cloud services. Also, it opened the model in RASON API so that you can communicate with the server. This is one way of communication with RASON server. I showed you can click on those buttons to post your model, run them, and get the results. But this is not what you can do. There is much more. You can actually, let me get, you can have different other clients that now can use your models that are cloud services. You can have a mobile application. You can use Power Apps. You can have a web page, web application that communicates and uses your model as a cloud service, Power BI, or you can have your own Windows or server application. And actually, Create App shows you examples of creating a web application that communicates with RASON server, Power BI, and also Windows or server application using Solver SDK. Okay, so I just wanted to give you another visualization of what we're trying to accomplish. So let's continue. Let's go back to RASON.com. I want to explore it a little further with you and show you the standard REST API endpoints, how to post the model, get the results, now that you are more familiar. And then we can continue with Create App to go further, okay? So let's go back to RASON.com. Now the terms are more familiar. So here you can see the model components. And let's use the highlighter. Down here, you see the outputs of communication with the server. On the left, on the model section, these are all the models I have on RASON server. And on the top, are all the options you have to communicate with the server, which are, okay, I hover over them. You can create a new blank model document. You can post the model, so post to RASON.NET API model. Then you have option to put the model. So we are following those HTTP requests. Put is when you're actually just updating a section of model. So you don't need to create a new version. It just updates the existing model. Then you have this model execution. If you recall, there was post solve, post optimize, post simulate. Then you have stop. It's a post get status, gives you a status of what is happening. Is it completed, not completed? And then you can get the results and then get the data. Furthermore, you can use create app from here and also access RASON example models. So you have different optimization models, simulation, data mining, decision tables, and decision flows. These are multi-stage decision flows that you can use in your further for your projects or your application. Okay, now let's go back to Excel. I know that time goes by really quick, and I'm going to show you some more uses of this create app. So let's go back to create app. This is our modern Excel. Let's click on create app, and let me show you. We have a deployment wizard. So time is limited. I can't show you all the options. So if you're interested, click on deployment wizard. It walks you through the steps of other options that are available to you. So it helps you, you know, you want to deploy your model, but you don't know what you want to do. And it actually gives you all the options that are available. So it gives you some ideas. Okay. So that's one thing you can do. Just click on create app. Another one is manage models. So click on manage models. This actually shows you how interconnected Analytic Solver and RASON are. If you recall, this is exactly what you saw. All the models I have under my account on RASON.com and on RASON server, right? So these are all the models I have. And then on the top, I can choose to see only RASON models, or I want to see my Excel models, okay? So I can kind of see which ones are Excel models, which one are RASON models. I can delete them from here and manage my models on the cloud, okay? On RASON REST API. Now, let's go to create app. Let's work with Power BI. I know this is a little confusing. I promise you, you will master this readily. Frontline has made this very simple. It is just maybe unfamiliar, but addition to these live webinars, you will have a lot of educational type documents. RASON has very nice user guide and reference guide, and we are also making a lot of demo videos available to you. So Power BI. So with Analytic Solver, we built a simulation model. We deployed the Excel model as a cloud service, and we also deployed the Excel model as a cloud by using the RASON model and Excel model. Now let's move on to Power BI. We want to go beyond the Excel by creating a custom visual from our simulation using Microsoft Power BI as an example. So our goal is to quickly call a model on RASON server using Power BI and display the results in Power BI without any code. So let's try the first option, Embed Model. This creates a custom visual, invokes the model, and creates a custom visual for use from this model that we have. So let's give it a name. I call it EE and click on Save. As soon as I do that, two prompt windows appear. And after several moments, both will disappear. During this time, the custom Power Visual is created from our model. And while this is happening, so these are the two command prompts that are running. Let's open Power BI. I have the desktop version. You can work with the cloud version. And you can see this is completing, creating a custom visual for us. Now I have the Power BI open. There is a visualization section. We have to import a custom visual. There are two ways to do this. One is through this three dots here. You can use this. import a custom visual from a file. So let's erase the drawings. Another way is to go to File, Import Power BI Visual from File. So there are two ways to import this custom visual that's created by Create App feature. So let's click on these three dots on the right side, import a visual from file. This is, I just gave 4 E's to it to be quick. Click on open. It is imported. You can see there is this Frontline system icon here. And if I hover over it, it just represents the correct name. As I click on it, gears start running. It is communicating with RASON server and displaying the results for us for I-35 and K-35. So this was how you can create a custom Power BI visual from your model in Excel. You can do this with the Excel Online using Analytic Solver cloud version also. But this was just a desktop version. You can create Power BI visual from the models that you have already posted to the cloud. I just want to show you, but to save time, I'm not going to do that. So you can go to Power BI, manage models, and then it asks you which model you want me to create the custom Power BI from. And then you have to tell the model name. So what I usually do is I go to manage models, and then you can here select the model that you want. For example, one of the RASON models or Excel models, copy its name so you know which one you want to create the Power BI visual from, and then go to Power BI, manage models, and select the model name, and then it creates a custom visual from the model that is already posted to RASON server. Okay, so there are two ways to do this. One is create the custom Power BI visual from the Excel model from scratch here, or you can invoke a model that is already sitting on RASON REST API. I hope this is clear. Let's skip this one, and you can practice it on your own. Same step, just call the name and then it creates the visual for you. And there's a very nice chapter in user guide that walks you through the steps. Okay, so let me show you the web page, and then I want to show you that at-risk from Palisade. Okay. Another thing you can do with Create App is to create a web page from the model. This is another way that we show you how you can post your model to RASON as a REST service, and then create a web page to show you how you can have your web application and communicate with RASON REST API. This is just another example. Click on Quick Test Web Page. This automatically creates a web page for you. You can see this is the HTML web page. This is the browser. Our created web application from our simulation model. This is the model. You can see this is the simulation software practice. This is the model formulas, again in RASON modeling language. And the outputs. You have some endpoints to solve the model. So let's click on solve. It will actually post and solves it for us. It's still incomplete. Now it's completed. It gives you all the trial values and your variance. Remember, we requested the variance on the workbook. If you right click view page source, you can see that this is a basic HTML page that uses simple JavaScript. This is a template that's available to you on the RASON file and help documents and examples. You can actually change it and modify it as you wish, but it's available to you as another example of communicating with RASON server. So here is the model component in RASON language. After the model components, we have some examples of showing you how to make AJAX calls to RASON REST server. You can see that we have quick solve calls. This is how to connect with different endpoints to solve the model and get the results and delete the model. Okay, now let's go back to Excel. I have this at-risk model. So what I want to show you is that with at-risk models with Analytic Solver. So let's click on the Solver ribbon. So when you have the desktop version of Analytic Solver, when you have a license for Analytic Solver, you can have access to Analytic Solver cloud-based version. And the cloud-based version is available to you from the convenience of your browser. You can see the ribbon is very similar to what you just saw in the desktop version. You have the create app button available to you. It actually now asks me to log in. And you have to check your license out from the desktop version to the cloud-based version so you can switch your license. That's why one license can work with both. It validates my license. Okay, this is the create app. You can see it's exactly similar. This is the cloud service which we practice together. This is the quick test to create a web page, and the Power BI, as I showed you, there are two ways to do this: deployment wizard and manage model. So this is the at-risk model. It's really easy to change the formulas in at-risk to Analytic Solver. Literally all the functions that are available in at-risk are available in Analytic Solver, and we also offer much more. And you just have to update them. Formulas are very similar. Basically, at-risk would be replaced with at PSI. And if you have a question about that, reach out to me. And what you can do is just to go to simulate, and then I want to show you that you can actually solve the model in the cloud-based version, okay? And you get all the charts available to you. You can now, with the model that you have, you can access all the full power of deployment and use RASON and much more, which are not available in any of our competitor products. Okay, let me show you. You can actually, let me show you the RASON offers you much more. So this is just demonstration of our graphic editor that allows you with drag and drop, you can create your own multi-stage flows, decision flows in RASON. So I have this software product simulation. Then I have a decision table to make a decision. And I have the decision table in Excel, which is easier to understand. So something like this. Look here. So I have a decision table. You can create these decision tables in these business rules and DMN compatible decision tables in Analytic Solver, RASON, and all of our products. So it's really easy to do that. There's a nice chapter, and you can just go to on the model, you can see there's add decision table, add rules, add decision function. So you can practice with that and look at the examples. Basically, I get some information from the simulation and make a decision. Hey, if number average duration is this much and then average cost is greater than 3,000, I need to get a loan from Bank of America. If the weeks are between 60 to 80 and any for any budget that it needs to finish the project, my investor would help me. Or if number of weeks is less than 60 weeks, I really need some quick cash. So just to show you what you can do. And basically now in RASON, you can create this multi-stage flow, start with the simulation, run the table, and feed the simulation outputs to the table with creating these connections. So one of them is cost, one of them is duration. This is the input variable duration. The other one is cost. And you can see this is the I-35 mean. And then you can quickly run these flows and solve them and get the results. It's still incomplete, so let's wait for it. It just we can click on get status, and it gives us the status down here. Now it's complete. Let's click on result, and it gives us the calculation result, and it says use their investors. Okay. So I know this was a lot of information, but I wanted to just know there's much more available to you when it comes to RASON, deploying your models, multi-stage workflows, and these are all available to you, and they're really easy to use. Okay. Let's see. Now let's have a summary. This was an introductory webinar to give you a sense of what you can accomplish. Analytic Solver offers a wide range of tools to make analytic-based decisions when dealing with uncertainty and risk. You have the full power of stochastic optimization, Monte Carlo simulation, risk analysis, and decision trees. And we just looked briefly at simulation and deployment using Analytic Solver plus RASON. Analytic plus Solver plus RASON is a complete decision management suite that supports the full range of business rules, forecasting, machine learning, optimization, and simulation, from small to large models, multi-stage analytic workflows. And you don't need to be an expert. You can start from the first steps, deploy your model, solve it, and it just works, you know. But if you want to take it too further to a more advanced, complicated, use schedule time to run your models and everything, they're all available to you. Okay, so this is another summary slide. RASON enables you to leverage your business expertise and Excel skills for model creation, deploying your models, and manage your data via different tools: Office 365, Dynamics 365, Common Data Services, OneDrive, and CData. You are offered OData standards. RASON enables easy use of analytic model results as OData and JSON formats, okay? Data connections are really easy to set up in RASON. These are more advanced versions, things that you can do with RASON to create connections using your account. And I showed you can really easily create multi-stage decision flows with automatic scheduling and setting different options. So this is another wonderful tool that's available. With that graphical editor, you just need to drag and drop and build your flows. And it actually automatically creates the code for you. Your next step. So please feel free, download the trial version of Analytic Solver, create your trial account on rason.com. You are always welcome to contact me at sima@solver.com or consulting@solver.com if you have further questions. Again, you're welcome to join our webinar next week on data mining, features of Analytic Solver and RASON. I trust this webinar was helpful. I really appreciate your time. Provide us with your valuable feedbacks and comments on how we can improve your experience. Thank you very much. I'm going to answer your questions now. And again, we are welcome to download the product brief available. To the best of my knowledge, there are no other integrated products similar to RASON, especially when it comes to simulation and risk analysis. We are the really top choice that is available to you, especially with the speed and all the other tools that are available. Our risk solver products are by far the fastest Monte Carlo and risk analysis products available. And when it comes to optimization, I mean, Frontline systems, and we are the top, we are offering the top choice. Okay, if you have a question about security in RASON server, you actually have different security options, and you have, if you go to account, you have different tokens, private tokens. So there is a lot of security discussions that we didn't even discuss, but these are all available to you. Okay, so this is really, there is a lot of information available to you if you're interested. And Peter asked about the sensitivity for the scatter plot. I believe you are right, but I can check that answer for you. I have to go back, and there are multiple options for correlations actually available. So let me quickly show how to induce correlations as I promised. So let's see. So let's see how we can induce correlation between two different uncertain variables. So let's click on correlations button. There are different correlation options available. Peter, if you're still here, Mr. Walker, rank correlation, and a few more options. And you just select your variable. Say we want to induce correlation between market analysis and design, or design and implementation. That makes more sense. So let's have F16 and F17. You just select them on the left side, move them to the right, and then you can either double click to enter the value here, the correlation value, or select this chart and move the correlation. Okay, in this correlation, click on accept, and then you can give a name to the correlation. Let's call it core 1, and then you have to give it a location. Let's paste it here, and once I click save, there would be a correlation table inserted here for us between these two variables. And what is cool is that now the two uncertain variables, let me show you the formulas. Remember, first we had PSA triangular. Now between these two variables that are correlated, you can see a new argument is added, the correlation matrix. So this shows that they are correlated. So it's really easy to set up correlation. Okay, if you have any other questions, please type them in the chat box, and you're always welcome to explore our tools and reach out later. Again, my email is simo@solver.com or consulting@solver.com. I'm going to be here for another few minutes for your questions. Thank you very much for your presence today. Really appreciate your time. Have a wonderful rest of the day. Okay, I'm going to end the webinar. Have a wonderful rest of the day. Bye for now. Thank you. Bye-bye.